So anytime you are dealing with this higher order constructs and then the lower order constructs, the very first stage that you are supposed to consider is that with the lower order construct, you are supposed to assess the validity and the reliability. So if it is reflective, these are the criteria which you have dealt with before. And the threshold. So alpha should be more than 0.7. Um, reliability more than that, and then the inner VIF should be less than 5. The discriminability should be less than 8.5, 0.85. So the same way, if it is um, a higher order construct, we assess the VIF, which is supposed to be less than 5. Ideally, it's supposed to be less than 3.3, but they are all justifiable. So it depends on the kind of risks that you're dealing with. Sometimes your constructs are highly correlated. In that case, you can go with the threshold of less than 5. And you cite your source. But with formative constructs, you will not be able to assess your alpha and reliability. Okay. So what we use to check the criteria or validate the reliability and validity, we use the VIF or the cardinality. And then we check for the outer weight, okay, to see if it is significant or if the T value is greater than or equal to 1.96. So if it is more than this or equal to 1.96, you're going to get a threshold of 0.05 for the p-value. Okay. So if it is between or if it is less than 1.96 absolute, it means that you're going to have your p-value greater than 0.05. So if the weight is not significant, you check for the outer loadings. So the same way with our low order construct, sometimes if you have a very low loading, indicator loadings, you try to delete some so that you see if it is going to improve your overall model, or if the other criteria will be met. For example, the AV. The same way, you check the outer weight if it is significant. If it is not significant, we check if the weight is not significant, we check the outer loadings to see which ones we can delete. So far as it's not significant with the weight, we don't delete it, but we have to check for the loadings. And if the loadings is the threshold is greater than 0.5, you have to retain it. If it is not, you have to delete it. So if the weight is not significant and loadings less than 0.5, we consider removing it by justifying this theoretically. So let's try and go through them one by one. So we are going to begin with this one. So this is what we did yesterday. But let's try and go through once again so that you better get the understanding. So now you understand that this is the institutional quality is our higher order construct. So let's try and then go through the reflective, then we come to reflective, formative, and then so on and so forth. So let me see. We have the data access, platform quality, and then learning supports being our lower dimensions of the institutional quality. So let me delete this one. And we are dealing with reflective. What does that mean? It means that with reflective, reflective. The lower order constructs are reflective, and then the higher order constructs are also reflective. All right. So it means that you have to create our higher order construct somewhere here and call it institutional quality. Okay. So if the lower order construct is reflective, it means that the arrows are pointing out towards to the indicators. Now, the subdimensions now becomes the indicators for the higher order construct, which is being termed as institutional quality. So essentially, it means that for this to be reflective as well, the arrows should point towards that respectively. Okay, so this is it. And now we are looking at institutional quality as the higher order construct, serving as serving as independent variable, and then predicting academic outcomes. So you can also add, I think we have some few left. Let's see if you can add maybe let's treat B, which is the overall engagement, as another dependent variable, such that that will be behavioral. So behavioral, uh, let me check the spelling. Is it right? Is it behavioral? Behavioral engagement. Mr. Bonsu, is it right?
That's dog.
Okay. This American and English spelling. Yeah, yeah, you use the British
I think this
English.
one is British, yeah.
I've been using the
Or
British,
American. This is American.
this
This is
American
American.
behavioral.
Yeah.
Let me check Google and see. Behavioral, I think there's no I. Let me delete this
Yeah,
one.
there's no I.
Thank you very much. This is Melinda. There's no I here. And then you have been saying behavioral, behavioral. So it is behavioral engagement. So let's treat this one as, let's see, a reflective independent variable. So here, because this is alone and this is also alone, now we have two main independent variables. So this is our higher order construct dependent variable, and this is our lower order construct. This is our higher order construct independent variable, and this is our lower order independent variable. All right. So that we see the difference between formative and then so that we see the difference between higher order construct formative and then lower order construct formative. Very good. So what do we do? With the repeated indicator, you're supposed to drag all the indicators that we see here also into um, the higher order construct. All right. So we can just easily select them here. So you just hold the shift key and then use the down arrow key. It will just be highlighting them for you. Now you just put them here. All right. Now let's bear in mind the arrows can also be invented, right? But what are you dealing with? You are dealing with reflective, reflective. So this has to be reflective, and then this also has to reflect to the respective indicators. Now the arrows of the subdimensions, the sub-indicators of the subdimensions are reflective. So it also has to be reflective in here. So you have to invent it so that this move towards the indicators, this also move towards the indicators for each of them. All right, so we can hide this one. Now, what do we do? First, you're supposed to check the reliability and validity of the lower order construct. So let's go ahead, run the PLS algorithm, and then we can just hover on our screen on this. I think this has been met, this has been met, this has been met. Mm. Then this has also been met, right? So let's check our, so with reflective, we are not going to consider the higher order construct here because we are not assessing for, at first, we are not assessing for the alpha and then the AV, which is the validity, the conversion validity. So once this have been met, we have to report this. Okay. So we can just copy that to Excel. But when we are doing that, we are not going to include the institutional quality, which is the higher order construct. Anybody want to say something? Okay. So we check for R square. I think this is not bad. Um, let's see our discriminant validity. You're going to check our R square for the main dependent variable because we are treating academic outcome as our dependent variable. Okay. So the R square is actually the 0.601. So now that we have met the measurement model for the measurement criteria for our lower order constructs, can go ahead we can go ahead with creating the data file for the latent. So we can call this one reflective. So this has been created, right? Then you come and select the data again. So you come back, you select the data set. Then you delete these ones, the sub dimensions. All right. Then you also show the indicators in here. Make sure that you delete the right one. So if you don't want to be deleting the other, then just come back here now. Select it carefully, then you delete. You press delete. Now when you scroll down, have you selected the reflective? Yes. So when you scroll down, you are going to have the latent score here. So that is the data access. So now this is a proxy for the data access. That is the latent variable score. You can just bring it inside and then learning support also come. And then what else? Platform quality. Okay. So for this one, you can edit it and then rename it. You can even increase the size. So now this is our reflective. Let's now run and then validate only the higher order construct. Okay. So now this is our square, the same value that we see. And let's go and check. Because we are dealing with reflective, we're supposed to check for the reliability. Okay. So now you can see that let's see our average variance extracted. So the higher order construct. So this is below the threshold, 0.345. And let's see this one. This is also very low. This is very low. This is also very low. So this criteria has not been met. Okay. So this is a very big problem. If you're dealing with higher order constructs, reflective. But I believe we can argue that based on my research, I found out that most of the times we assess the reliability at the lower order constructs. Okay. Because the questions were set based on the respective lower order constructs, and then we now came to compare them. So I think you can base your argument on why this is the case. But ideally, you're supposed to have your average variance extracted to also meet these criteria. That is when you're dealing with um, reflective, where one is higher order construct and then another is lower order construct. So you can also check your VIF, everything is okay. But we are checking for the ones here. Okay. And then what else? You can check your F square. So with reflective, we don't really base our focus on the outer width. Okay, so let's try and do another model where so let's look at the type 2. Type 2 is the reflective formative. So it means that the first or the lower order construct will be reflective in nature, and then the higher order construct will be formative. So let's see how that will also be depicted. So I think that's what we did yesterday. Um, Let me undo. So the only thing that is going to change is that we are going to invert the arrow here, because with reflective and formative, the first order construct is reflective. So as we can see here, the arrows are pointing to us. But they now come to form, the sub-indicators now come to form the higher order construct. So that is what we term the reflective formative. So as it stands now, what we see here is the reflective. So this is reflecting to that. And then the higher order construct is reflecting to the sub-dimensions. So reflective formative, this will reflect to respective sub-indicators. And now these dimensions now will come and form the higher order construct. So the only thing we're going to do is that we're going to invert the arrows. Okay. So we're going to delete this one. And then remove this one to that, this one to that, this one to that. Then we run our model. You realize that this is still the same because we are dealing with reflective. So once this one comes inside, because this is reflective, this is also going to be reflective. Okay. The only thing that is changing is that now the sub dimensions are now forming the higher order construct. So that is the reflective formative, as you can see here. The sub dimensions now come and then form the higher order constructs. But the sub dimensions, the indicators of the sub dimensions are reflective on its own. Okay, so the only thing that changes is this one now coming to form that. But if we are doing a repeated indicator, because this is reflective, then in here it's also going to be reflective. Okay, so that's why you see here. This is also reflective because the higher order construct is now moving towards the indicators. So let's run to see that we have not left any variable out. So once you get this, it means that everything is explaining that. So the same way, you can just check your validity and then reliability. All right. Just, I think we have already done that earlier, and we have met other criteria. We are not going to consider this because this is going to be done at the second stage. Now, we are supposed to create the data for this, right? So let's go to the report again and create the data. We can deselect this one. We can call this one um, reflective formative. Reflective formative. Then you come back to edit, you select your data, and then you select reflective formative. Now, what is going to change? You have now converted this one to um, a proxy that represents the data access. Okay, so we're going to delete these ones. Again, the same approach. You have to be very sure that you have selected the right thing. And then we also delete the elements in here. Now we have data access. By this time, it is going to be what? Okay, let me see. This time, the second the higher order construct is going to be formative. So we are going to reinvert, or we are going to invert the measurement model this way. So you can open this one so that it can be very visible. Okay, so now we have to validate the higher order construct. Okay, based on what we learned today, we saw that you have to check the VIF less than 5 and then the outer weight to see if it is significant. So we're going to run the bootstrap to check that, and then if the weights are not significant, you're supposed to retain it. So we are supposed to check the threshold, and if weights are not significant and the loadings are less than 0.5, that is why we consider to what delete it. All right. So let's run that and see. Already have run the PLS algorithm. Now let's run the bootstrap to see the significance of this. Let's see if you can see the weight here. So let's check the weight. Let me run this again. Okay, so you can see the weight here, the outer weight. You can see the outer weight from the PLS algorithm. So the outer weight for the higher order construct, already have validated this one already. So we are not going to consider that, but let's see this one, the respective proxies. So this is 0.7, 0.4, 0.50. So now let's check our VIF. Our VIF is less than the threshold. So let's come back and run a bootstrap. Okay, so the outer weight, we have the p-values to be significant. So it means that we are not going to delete anything from the data. So the latent variable score significant, significant, significant. So assuming that, let's say one of these elements, yeah, assuming that one of these is insignificant, it means that we're supposed to check the outer loadings to see if it is significant or not. So if the outer weight for, let's say, digital access was not significant here, assuming that this was not significant, so let me copy this one to Excel. So assuming that we have here to be, let's say, 0.210. So it means that this one is not significant. In that case, you cannot just go ahead and delete it, but you have to check the outer loadings to see if it is significant. All right. And then we check from here, realize that the p-value is also significant. In that case, we're going to retain our latent variable score, though the outer weight was not what significant. So that is the idea. So if weight is not significant, you check the outer weight. You check the outer loadings and then we retain it. So now we check that and then realize that the p-value was what? Significant. All right. Mhm. Now let's look at the other one. Formative and then reflective. So this one means that the lower order constructs are formative, and then the higher order construct is what? Reflective. So it means that, let's undo this one. It means that at the lower level, this has to come in for this one. This one has to come in. This one also have to come in. All right. So in that case, we are supposed to invert this one in what? Invert this one, invert this one. Now because every element in here has also been dragged into this higher order construct, this also has to be the same invert. But we are dealing with reflective, we are dealing with formative reflective. So it means that we're going to rather move this arrow towards that one. Okay. So that this one will be formative, and then the higher order construct will rather be reflective. So the arrows has to be this way. All right. So we are going to delete these ones. Then we connect this one. So this is the formative reflective model. So you can hide this and run your PLS algorithm. So what are you supposed to do? You're supposed to validate our lower order construct. Already have done that. And then with the higher order construct, what do? We create the data. So let's create that. We can see that in the full. And then, so let's create this one as formative reflective. So this data is named as formative reflective. We can check this one. So the data file has been created. Then you make sure that you select formative reflective. All right. Now you can delete this one. Now you have the corresponding, you have um, the corresponding latent variables. Well, let's see. I think I didn't delete this one, so let me show that. And then reinvert back, and then select everything here. Good. So now we have digital access, digital access, learning support, and then platform quality. Good. So now we come back here, and then we invert this one. Good. So now we can run. This time, because this is reflective, we are supposed to check using the normal approach that we know. So how do we check? We are not going to check for the outer width. We're going to check for the reliability. Okay, so here, we didn't meet the criteria, right? And the alpha is also very low. Let me check. Okay. Is there any question so far based on what you have done? Any question? Start do. And Ms. Belinda, any questions so far?
Yeah, yeah.
Okay.
It's okay. Yeah,
Yeah,
I'm
okay.
following.
Yeah, so with this one,
A question?
okay, go ahead.
Yeah, my question is that the behavioral engagement, we are not running on it, but it's still in the model. Why didn't we delete it before running?
Okay, we didn't use the
Will it be
latent variable.
contributing to? Yes.
This is on its own, right? So we don't see that it is in here. This is seen as an independent variable on its own, but it is at the lower level. So for this one, you check only the reliability using the alpha, AV, um, the CR to check the reliability and validity for this one as well. But we are also adding this one so that we compare how the treatment will be for higher order construct and then lower order constructs. So now this is a lower order construct, and this is a higher order construct reflective. So this is a reflective higher order construct, and this is reflective lower order constructs. All right. Is your question clear?
Yes.
So the same way, once this is reflective, you have to check, you go by the usual means, check your AVE. So here, you want to validate the higher order construct, not the lower order construct. And we didn't meet the criteria. You see, we're using the same data for all of these demonstrations. That's why probably this is happening. But if you create your questionnaire with your theory behind what you want to do, it means that you are supposed to meet all of these criteria. But we are just using the same data to illustrate how it's going to be. So definitely there's going to be something wrong somewhere. But we are supposed to ensure that this criteria has been met. For the reflective, this has to be greater than 0.7. The same way for this one. You check your discriminant validity, and this is also supposed to be less than 0.85 for this one, this, and that. So the issue is with the institutional quality and then this one. So you can see this is even more than 1 point something, something, something. And then you check your VIF as well. Okay. So I strongly believe that if you have the right data with your right theory, you should be able to get things done correctly. So we can illustrate the last one, which is the formative. So formative, it means that now this is formative from the subdimensions. And we have gotten this one also right, because this is also pointing inwards the higher order construct. The only thing that you're supposed to change is that this has to rather move towards this. This has to move towards that. Okay, so you just have to select the lines in here. Then remove the arrows inward. Then we run our PLS algorithm. You can hide this one. Then we run our bootstrap to check the weight. Okay. And then that's it. So that we know whether we are supposed to delete something, or we are supposed to compare that with the outer loadings first. If that is not significant, that's where you go ahead and then you consider removing or not. So let's check the p-values of our outer weight. So we go to reports. Okay, we can even see that. Okay, we didn't show. You can see the weight in here. I show the p-values here. But let's go to the open for report and see it in full. So the weights. Okay, let me see. We didn't select the right data. So let's select that here. Did we create the formative? Okay, so let's do that. I don't think we did that. So let me show this one. Okay, so now you're supposed to run this PLS algorithm and start calculating. Then you create your data, the latent variable score that is going to be used for the formative, right? So this is formative. Now we have finished creating that. Go back to edit. Then we are supposed to delete these ones. Delete these ones. And now select the right data. So formative. And then we have the data access here. We have learning support. And then we have platform quality. And don't forget, we are dealing with formative. So this is supposed to point inwards, right? Good. Now we can just run our PLS algorithm to check the weight, whether we are supposed to delete one of these. So now let's check the weight. Let's get where is the p-value. Okay, we don't see the p-values in here, but these are the weights. We have the weight to be 0.7, 0.385, 0.482. Now let's compare and see. So the threshold for the weight is supposed to be greater than 0.5. So if you check here, this is 0.3, this is 0.482. It didn't meet the criteria, right? So, but this one has met the digital access. But we cannot just go ahead and delete these two and say that it is not really forming the higher order construct, institutional quality. So what we do is that we compare the outer loadings. But how do you get the p-values? We're supposed to go back and run a bootstrap. So let's run a bootstrap. And once we run that, we go to the loadings and then check for the learning support and then the platform quality, which didn't meet the criteria. So now once this is significant, it means that you can go ahead and retain it. So assuming that one of these is not significant, you have to delete it from there. You have to delete it as an indicator, to the main. So one of these, if this didn't meet, you're supposed to delete that. And you're supposed to support that with theoretical reasoning why this was deleted. But don't forget with formative, once you delete any of the indicator, the higher order construct becomes something different that you're looking at. Okay. So some of these things I've never seen a study before, this higher formative, because with the social sciences, it's basically formative in nature. That is why it is not really common. I'm yet to see a study that has used formative. Okay. So with this one, we are finished validating that. We can go ahead and check p-values, whether it is clear cut or not. So you check institutional quality. The estimate is 0.35, and then it's significant here. You can also treat this one as maybe a mediator. Okay, so once you do that, you're supposed to run and check as well, and then go to Bootstrap to see if it is significant or not. So let's see this one. So that is significant. If you want to see your mediation, you come to specific indirect effect, and this is the result. All right. So the mediation is on behavioral engagement, and the estimate, the t statistics is more than 1.96. So that is it. We're supposed to check for your VIF of the higher order constructs. So let's check that. I think we didn't do that. So you can check that from here. So the criteria have been met. But the higher order construct will not show because we don't check for reliability and validity using these criteria for higher order constructs. All right. And then the higher order construct will also not appear because we don't validate using ATMT for higher order constructs. So that is it. I think that is something that we are supposed to know from now. Aside that, there's nothing new in SEM that we've not dealt with. Okay. Any questions so far? So I think with this knowledge, you'll be able to at least do your own research with SEM, whether you want to do the usual lower order constructs, and then if you want to go further with the higher order constructs. So this is the second order construct. You can even have third order constructs as well. So that is the very few information that we can share with ourselves, and we can go ahead with communication.
All right, Doc. So, when we are running the data, after maybe you have drawn the diagram, you have put the variables into its position, and to run them either in PLS or Bootstrap. Mostly the next stage we have factor, we have path, we have path safe, and we have PCA.
Yeah, okay, so if you want to do factor analysis,
this part, very good.
Yeah,
So we have factor, path,
so this
PCA.
is for factor analysis.
Okay.
But if you're doing okay, go ahead.
Okay, so I've observed that most we use the path, so that's why I want to know the difference between the other two.
Oh yes, if you are dealing with for SEM, it is path analysis, right? Previously,
Okay.
if you're doing regression, it more often factor analysis that we do. But with SEM, it is always path analysis. We are looking at this to that. So this is the path. The path is from this one to that, this one to that, this one to that. And that's why we always select path. And then we always select the standardized as well. So the values are all standardized values. But when you see the report, it also comes with unstandardized. But basically, we always select the default. So standardized, and then the initial weights, these are always on default. Okay. So that is it. So let's see the PCA. This is the principal component analysis. So let's see, is there any change? Let's see the factor. So this is 0.8, 0.7, and then let's see. Um, has there been any change in the values? Let me see reports. So I can compare this one with, or I can save this one as this one is the normal path, right? So let me add path to it. Let me create a new dip. And I can come back here, run, PLS Agrarium, and then select PCA. Good. So now I can save this one as PCA. Good. I can compare. I can compare this one to the path. Okay. The one that we have right now was the PCA. So let's see. Let's see what is happening. These are the graphics. So I have to open this one. I don't know if you can see it clearly from your end.
Yes.
So let's see if there's any change in the values.
Yes.
So this is 0. So this one didn't change, right? Okay, the rate, the loadings in here for this is for which one? This is the PLS path.
Yes, PLS
Be
path.
sure that we have selected the right one. So let's compare the PCA with the path, right? So this is the PCA, and this is the path, the one with the path.
Okay. So I think for the PC,
So the loadings are
there's
different,
still
right?
there's difference here.
And even this one is 0.592, and this is 0.593.
93, yeah.
The R square for the path is 0.405, and this is 0.392. Okay, so that means there has been a change in values. So I'm sure the PCA
Almost.
considers it uses principal component analysis. Okay, that means it uses dimension with reduction. I think somebody asked that question yesterday. So I think this is the
Okay,
difference. So I think the difference is with the approaches or the algorithm that runs the two. So this one uses the normal, it uses the path coefficient, and then this one uses the principal component analysis. Something like that. So you can toggle the orientation. Okay.
Okay.
So if you want to see more, think. So that is it. I think you have the room to explore more because this is the very first time I've been comparing models with SEM. I've been doing SEM for a very long time, but this is the very first time I'm comparing models. So any other question?
So based on this, based on the comparison, where would the judgment lie? Will the judgment lie on the considering the p-value, the one that give us a higher p-value?
Okay,
not the p-value,
uh,
sorry, the R
for
square.
normal SEM, with SEM we even have consistent SEM. I don't know if you have seen this one. Consistent PLS algorithm. Okay, so with the standard PLS algorithm, you normally select the path because we are dealing with path. Partial least square deals with path. Okay, so that's why we always use the default path and then standardize values, and then we just calculate. So that is, maybe it depends on what you want to do. I know the reason why you want to choose the PCA, but for all that I know that we always use the path because with the algorithm we use the path coefficient. Unless maybe you have any idea about why you might want to go for the PCA instead. So we can search that and see. Um, let's try Google. So in SmartPLS, the path waving scheme, that is the default, is supervised. Iterative algorithm maximizing the R square. So you can, I think we saw that the R square was higher than that of the PCA, right? So this one uses a weighing scheme, that is the default. So it is supervised. So I think it's more of machine learning. And then it does the iterative, it runs that, and then it maximizes the R square of the endogenous constructs by considering both the inner and then the outer measurement models. Conversely, the PCA analysis is an unsupervised dimensionality reduction technique that computes construct score based solely on internal correlation and then ignoring the structural model. So that the PCA does not consider the structural model as part of the analysis. And then it's also unsupervised. So these are the two key differences, right? So let's add the factor to
Okay.
it. The factor. So this is saying that this scheme mimics traditional factor analysis. So that this is a traditional factor or the component-based SEM, that is a CB SEM, by focusing on maximizing the correlation between indicators and their respective constructs. So it is generally used when researchers aim to measure latent construct more in line with common factors model assumptions. So let's see the key difference. The path maximizes predictive power. The factor maximizes construct validity. The PCA maximizes explained variance of indicator. And then usage, we use the path. This is default for most models. Factor is reflective, and then it measures the construct. It tightly measured the construct. The PCA is rarely used in structural uh, modeling, but available for component-based estimation. Now, the factor weighing often yields lower loadings value compared to the PCA, which can overstate the relationship between the relationship by including unique or measurement variance. Okay, so I think that is the key differences. Thanks to AI. So the AI is very useful. Whatever you don't know, you just have to. Even Google has AI, so you can see from that. Even most of the journals also have AI. Let's see Scopus. Now, if you want to search for a paper, now Scopus asks you that do you want to use the AI feature? So going for, I believe that anything that you want to have more clarity on, that you can also make use of the AI. All right. Any other question? So this will also give you more information. These are some papers that we can So this is the original SEM site, and this is where they explain. So the AI summarized everything from here. So the weighing scheme, the factor weighing scheme, the path weighing scheme, this is the default, and the principal component analysis. So we all go by the default, and then we have now seen the limitations. The reason why we have to go for the weight. This one maximizes the house square. This one uses the traditional method of weighing, and then this is more of it reduces the house square, but it uses the unsupervised learning approach. Okay, so I think so far this is better. The path weighing scheme, because this one uses iterative algorithm. It runs the models on different subsamples over and over and over again. That is why whenever you are running, you choose it will ask you the subsample, then you choose on that. So it will run on different subsamples. Okay. That is it. Any other question? So let's run a factor and see. So this is a traditional factor analysis. Okay. So you can see that with this one, the F square are very high. Everything is greater than 0.1. Let's compare this one to when we use the path. Let's see the F square. Okay, this is also high. 0.1. So that has changed. Let me see this one again. Let's see the PC. And let's see the F square. Okay, so this one has changed slightly. All right. This is 0.17, but the other one was 0.16. So these are the key differences. But the judgment is based on what you want to achieve. But so far, I've not seen any study that has used this method of weighing. Okay, so more studies can be referred to here for better understanding of the sim. Other question? I think so far so good. If there is no other question, then that will be the end for sim. The same lesson that we have been doing. I'll just see if there are any questions or maybe there's something that you don't understand. I also talk to the executive and see if maybe we can go further because there are a lot of things that we can learn as well. But these are not PLS or these are not smart PLS. You can also learn FSQC. FSQC. So this is more of qualitative study. You can also add this one to SEM. All right. Fuzi set qualitative comparative analysis. And then you also have, so here you can read more about this. I think these are the people who invented it. Yes, this 2021. They have, this study is in 2021, right? So this is a recent study, meaning that if you add this approach to your study, you'll be able to give more insight to whatever you want to do. And I think this study is also there. You can also watch more videos on this, get more understanding as well. Okay. Any other question? So that will be it for SEM. So because this video will be posted on YouTube, probably somebody might watch it later on and then might want to inquire more about this. You can WhatsApp me on this number. Maybe you want the premium version of the software as well. You can also WhatsApp me. And any other software that you might want to use. If you want to have any question, clarity, and all of that, you can just WhatsApp me. I'll just respond. And my name can be found everywhere. Google Scholar, ResearchGate, LinkedIn. The name is still the same. But many other
Oh,
people
okay.
can be Allison. So If you don't see
Oh,
friend, you
your
can still.
WeChat is active.
Yeah, okay. WeChat is different. Let me just add that to um the WeChat. This
The
is not
software. And
WeChat. It
some
is
of the
this.
software.
I think WeChat is, yeah. This is how WeChat. So WeChat, when you set this name, I see many of
WeChat
us.
ID.
Yeah, WeChat ID, yes. My WeChat is for Chinese people, and all the Chinese people are on the platform, so
Yeah.
they know me. They know me already. Mhm. So that is it. Yeah. So thanks for joining. Where is that? Stop recording.